All right. Cool. This works now. Oh, it's delayed. Okay. So this is a talk about what I did. This is mostly a project over the summer. Reverse engineering Ford vehicles. This is about car hacking, right? And specifically, really modern vehicles, right? So sort of an introduction to sort of general automotive security, right? First off, terms are often conflated in this field. ECU. Most people have probably heard the term ECU before, I think, but it means two different things, and that's kind of confusing. It can be just the engine control unit, or it can be just any module in the car, like at all, just an electronic module. So anyway, that's just sort of general. And there are two separate systems that typically older vehicles have had, right? You've had like the infotainment system, and then you've had maybe the control system that does like the engine and like the power, right? And those are usually, or previously usually, two separate systems. And so you saw there have been a lot of exploits on infotainment systems using stuff like Bluetooth exploits, stuff like that, but there haven't been that many on the control sides, and also they were rather separate. And so with automotive security, there are a lot of interesting attack surfaces. I'm not talking to the microphone enough. Bluetooth stack, USB, Wi-Fi, cellular, but also physical attacks like through the CAN bus, and now in newer vehicles, Ethernet, right? And if you do compromise a vehicle, you can do a lot of cool things, like drive it around, right? Because the throttle and the steering, those are all electronic. So if you can compromise that, you could like remote control this giant truck or something. That sounds kind of cool, right? But there's also stuff like comma.ai, right? That's like an open source. You put like a little dash cam thing, and is open source self-driving, right? Also things like engine tuning, stuff like that. There's lots of reasons why you might want to find an exploit even in your own vehicle. I was just putting pictures of, this is the vehicle basically we're targeting. This blue Ford Maverick looks kind of gray in that one picture. Right, really modern vehicle, 2025, and so they're using lots of these new systems. Let's see. So what's Ford really doing right now, right? Most auto manufacturers are sort of doing the same thing, but we're transitioning to EVs, right? Like that's F-150 Lightning. We have apps to remote start the vehicles. And one of the more important things for this is we now have over-the-air software updates, right? Like I know Tesla sort of pioneered this thing, right? But cars get software updates now. It's not just how you bought the vehicle. And that's a really interesting thing, right? Because they update modules that like drive the car. Well, that just sounds interesting to me, right? Yeah, everyone wants OTA updates, and that means that vehicles are always connected to the internet, right? All Ford vehicles come with a cellular modem. That cellular modem is always 24/7 connected to the internet. And you're also blurring the lines between these infotainment and control systems, right? Tesla, Rivian, they all have a centralized architecture where there's just a single powerful computer like in the middle, and that controls everything. Legacy automotive manufacturers like Ford tend to not have that as much right now. In theory, they're distributed systems. Like if your infotainment module fails, in theory, you can still drive the car. If your advanced driver assist, your self-driving modules, if those fail, you can still have basic functions. It's all separate computers doing their own sort of job, right? So Ford, as part of that, created FNV is their new architecture. Yeah, here we go. This started in 2021. They announced it in 2020. Is this new architecture I'm talking about? And basically, they call it the fully networked vehicle 2.0. They didn't have a 1.0. They just called it 2.0 from the start because, I don't know, marketing. And basically, that's where they introduced a bunch of new, networking basically between all the modules, right? This is where they introduced Ethernet, and this is where they introduced a whole bunch of faster buses like flexible data rate CAN, which I'll get into in a bit. And then they've been building upon that, right? So in 2023 with the F-250, don't know why they picked that vehicle to introduce it, they have FNV 3.0. And this one supports having an Android automotive infotainment system, right? So you're running Android on the car itself rather than just like Android Auto, like CarPlay type stuff. And also it has some more security features like Tron authentication, which I'll also get into. Let's see, what was I saying here? Oh yeah, so sort of central to these new architectures is something that they've been calling the gateway module. And cars have had this for a while. For security reasons, right, cars have multiple networks on them. So they separate things that are like maybe less important, like say the door locks, onto their own network. And then they have more interesting things like the engine has its own small network and it's sort of separate. But sometimes you need to send a message to the entire car. Things like, you're turning the ignition on. Every module needs to wake up all at once. So they had this thing called the gateway module, whose whole job was to sit like a router in networking, and just copy messages across the different buses. It was originally behind the OBD2 port, also because it needed to copy messages from the OBD2 port to the different buses for diagnostics. But when they added Ethernet, they made it this whole big module, and it sits in the center of the dash, this metal module they call the ECG, Enhanced Central Gateway. Yeah, that's what they introduced with FNV 2.0 in 2021, this new silver module. And that's basically what I'm going to be targeting here. This is all the networks they have. It's quite a lot. Well, each of those is showing the changes sort of with the different variations of this architecture, right? You started with FNV 2.0, which had a lot, like the MS, the HS, and the FD are different speeds of CAN buses. MS is very slow. And they've had that for a while, and they use it for slow things like door locks. HS buses are faster, and then FD CAN buses are even faster. Note that when I say fast here, FD CAN has a max of 2 megabit per second, so it's not that much data. But really, the important thing about CAN bus, right, is you're sending repeated messages. So really, things are scheduled in time windows. You're sending something like every 20 milliseconds or something, like just repeatedly forever. Like that's how these systems work. They're less individual packets and more just a repeating message that has a changing value over time. So anyway, yeah, they changed all the networks around for the different years for reasons that aren't always entirely clear, but clearly they're adding more of the faster ones and getting rid of the slower ones, right, is the general trend. But also an important thing we have here is Tron. I don't really know what Tron stands for, but it's it doesn't really seem to stand for anything. But anyway, it's or maybe I have it somewhere. Anyway, that's they call it encryption. It's not really encryption, it's message authentication. They add a little HMAC tag to the end of every message so that you can't forge them. Now, some auto manufacturers cut in, the problem with CAN bus messages on the older MS and HS CAN standards is they have a fixed length of 8 bytes. That's all you get. So some manufacturers chose to cut into that 8 bytes and add a message authentication tag to that, but that means you can't send very much data in each packet. So Ford decided, it's not that important to us. We don't want to cut down on the data. Instead, we'll switch to using FD-CAN. FD-CAN has double. You can do 16 bytes. So they just said, we'll keep it the same length. We'll have 8 bytes of data, 8 bytes of HMAC tag on FD-CAN only. And so we'll only secure the FD-CAN buses. The HS buses and the MS buses, well, you can still sort of forge messages on them. But that's not that much of a problem. Usually they moved all the important stuff off the HS and MS buses. They also have a couple other architectures that they mention offhandedly, but like these are the main ones that are shipping in vehicles today. There's an FNV3 AV, which is really interesting. They use that for their autonomous vehicle platform internally, like the fully autonomous, like that they're developing for like robo-taxis and stuff. I mean, basically that just means they have a whole bunch more modules with more sensors, and they like doubled the amount of Ethernet. Like there's like 10 Ethernet ports on the module instead of 5. They had FNV 4.0, which was going to be like an EV native sort of platform, right? There are a lot of different choices you could make if you're making an EV native platform. Like all modern Fords today, even the EVs have a push to start button. If you're going EV native, like Teslas don't have a push to start button. They're just always on. You get in and drive. That was maybe what they were going to do, but then Trump became president, and they decided to cancel that, like just at the same time. Maybe unrelated, who knows? Yeah, FNV4, I guess, is not going to happen, maybe? Not really clear. This is the module I'm targeting, right? And I actually have it up here as a physical prop. Let's see if I can. All right, can I get this maybe in the camera too? But it's just this metal module. It has a bunch of connectors on it. You can see I took it apart here in the picture. Um, and basically, it serves, I already mentioned the purpose of this gateway module, to copy message across to function as a router, right? And it's a central part of this new architecture. There are a couple versions of it. There was the ECG1, which was the first thing they introduced. It had like from NXP, their IMX6 ARM processor, and like a coprocessor that ran. There was one like on Power architecture and one that was on some other Renesas, I don't know, some other architecture for their coproc running like a real-time operating system. But anyway, then they switched. That was running QNX, by the way, which is an operating system for embedded stuff by BlackBerry. But then we have the ECG2, which is what I'm actually reversing, and they switched using Linux. Yay! So that's a lot easier. And there are also the coproc is now like just an ARM processor, not a silly Power IBM architecture. So that's much easier to reverse. So that's why I'm targeting it. And they've actually got a custom chip from NXP. Do I have a photo of this? Yeah. Basically, they got this custom chip designed by NXP for basically just their use case, and it has like a whole bunch of cool stuff. Like it has the ARM Cortex M7 cores. Like I don't know if you've ever like done like embedded microprocessor stuff. Like those, that's what they run their RTOS on, and they have like the bigger ARM cores running Linux, all on the same chip. So they don't have to have two separate chips. But also it supports like a crap ton of Ethernet and a crap ton of CAN buses like built into the chip itself. And a whole bunch of like hardware security engine stuff, so they keep their keys in like hardware. And like the cores are all lockstep to prevent fault injection. Like they really tried to make this secure. Here's a photo of the board, like sort of labeled, I guess. You know, there's this A is like the CAN bus connector, right? There's a whole bunch of CAN buses connected to that. C is where the Ethernet's connected. This is the LT version of the board. HT version of the board has that B connector also populated. That's just more Ethernet. They use that for the autonomous vehicle stuff, as I mentioned. You know, you have that main SoC, one, and then two, you have that that chip it's really big, but it's just an Ethernet switch. Like as big as the main SoC is an Ethernet switch, because they have like 10 Ethernet networks they need to switch. Yeah. Also, it's not normal Ethernet. They use this quote-unquote Ethernet master connector. It has 5 Ethernet ports in one, and you'll notice something about them. They only have 2 wires. So that's pretty interesting, right? Yeah, this is automotive Ethernet is apparently a thing. I didn't know. It's 100 base T1 instead of TX. They also have 1,000 base T1. They can do gigabit Ethernet over 2 wires. Yeah, I just thought that was interesting. But you have to get a special adapter for that, and I had to make a special cable. But I guess shout out to T Connectivity, the company that makes the connectors for Ford, will give you free samples of any connector. So I mean that's pretty good. But you have to crimp them yourself. That was annoying. Yeah, their modules connected. Probably spending a bit too long on little details, but there are modules connected to Ethernet. You have the IPMAs, the image processing module. The APIM is what they call the thing that does like the infotainment on the dash. TCU is the thing that has cellular. You get the point, right? This is like my benchtop setup right now. It's got a Raspberry Pi there connected to this 1,000 base T1 to base TX converter because the Raspberry Pi doesn't have automotive Ethernet natively, obviously. It's just a media converter. And like an OBD2 adapter, and I made a custom wiring harness to convert it to OBD2 just because, I needed CAN bus, and that was the easiest way to get it. This is the old architecture diagram. I think I have some, labels. But basically, this is the old pre-FNV way they layouted everything. You can see there are a lot of electronic modules in vehicles. I didn't maybe think of that there were this many before. And they're sort of segregated, right? You can see there's like the powertrain modules I highlighted in blue there. The infotainment system stuff is in red. And before the infotainment system, the APIM there, you can see it's in orange, had like maybe a bit more access. It could access like 3 of the different CAN buses, including the powertrain CAN bus, which was maybe a minor concern for them, right? That you had direct access from the infotainment system, which is, the thing that most people maybe compromise to the powertrain network. And remember, before this, there was also no message tagging. So if you could get control of that, you could forge messages on that bus. And that was problematic. So We're not doing that anymore. Now we have FDCAN, and you can see there's a much clearer segregation. The APIM has access to nothing else except for the other sort of infotainment things. It's not connected to any other network. It's not in a privileged position. Instead, there's this gateway module, which is now all privileged and has access to all the networks. But it sort of acts as a dumb router in theory, so maybe that's a bit more secure. And then, this is when also they started upgrading things to FDCAN, which is like the faster speeds. Yeah. Then we have sort of this one, FNV 2.1. They split it out into two diagrams for some reason. But basically, yeah, sort of the same thing, except there's more FDCAN buses. And this is when they introduced the message authentication, this revision specifically. Yeah, that's sort of boxing up things. There's the advanced driver assistance system. That's the IPMA. It does like the self-driving type stuff. And you notice it has a direct line to the power steering control module. I guess just, for safety reasons so that it doesn't accidentally like break that connection and lose control of the steering. So it has like a dedicated wires directly to the power steering. I had some slides on the Ford part numbers. I don't know if that's that interesting, but really they use a very strange system. That's really hard to figure out what they mean. But yeah, they have like what vehicle it came from ish and what year it came from ish, and then a section of the part and a number ish, and then a variant and revision ish that sometimes means a revision, sometimes it means that they use the same but slightly different in different vehicles with like a different config. All of this is very loosely defined and they break the rules all the time. There are like a million exceptions. It's very annoying. So basically, if you want to order parts for Ford things, you just have to call a dealer because they have like an internal database that has some of this information, and it's not like public anywhere, and there's no way to get the same information a dealer has that I have found. I tried very hard. There is just not a good way. Though there are like some things, there's a secret API I found that can look up the quote-unquote service part number and the engineering part number and like cross-reference them. They're two different part numbers for the same part sometimes. When you want to replace it and buy it, it's a different part number from what's actually written on the part. So yeah, you need this secret API to like look up between the two different part numbers. So that's, yeah. Also, the parts websites based on this simple part thing are better than Ford's own part websites sometimes. Don't really know why. Here I was going to do a basic thing about looking at Tron authentication, right? So this is like just a message in a CAN bus decoder, right? For I think this is like lane keep assist messages. Yeah, lateral motion control. But you can see it's 8 bytes long, and then all those bytes, that's the message authentication tag, right? Ford did not want to sacrifice and cut into that message. They kept the messages exactly the same. They just added on these 8 bytes here. Other manufacturers did other things, and they just like cut into their, like they made shorter message authentication tags and cut into their payload. But Ford didn't want to do that, I guess. Oh yeah, Trusted Real-Time Operation Network. I guess that's what TRAN stands for. Huh, I forgot about that. Anyway, SecOC is a thing by like the Society of Automotive Engineers or something like that. It's like sort of a standard, but like not very well defined because they basically say that automotive manufacturers can do like basically whatever they want. Like they can make it like different parts of it different lengths, which is how Ford's is 8 byte long. But I know some other manufacturers are like 4 bytes long or 2 bytes long. Like they get basically a variable amount of security depending on how much they think, I guess, people are going to brute force it and how long they think it needs to be and how much they're willing to sacrifice. It's a trade-off, I guess. Yeah. So this is like sort of diagrams. You have a secret key. They keep that secret key in like a hardware enclave. So in theory, you can't extract it. Key distribution. You sort of have the Ford cloud, and they have this magic database of all the modules they've ever produced. This is also, I think, sort of a right to repair sort of issue. You can't pair modules to a vehicle that aren't like official Ford modules in their database because the official database needs to give you the keys. Like they're sent directly from the cloud and unwrapped in the hardware enclave. So yeah, that's like, you can't use modules that aren't like official Ford modules, I guess. At least without breaking the system somehow. Yeah, did I have some other things? Oh, that's just doing an animation of the little keys there. Okay. Yeah. What was I going to say? Oh, yeah. How do dealerships configure modules? I was just going to go over this real quick. We have the Ford Diagnostic and Repair System, FDRS. It's an official Ford tool. You normally have to pay like a ton of money in licensing, like thousands of dollars a year to use it. That licensing can be bypassed. So, yeah. And basically, that's also how you do, like, if you want to add a new module, that's how you talk to the Ford cloud to get new keys distributed to all the modules, is you have to use that tool. There's the Ford PTS. That has all, like, the manuals with all the, like, the fancy diagrams I had before. A lot of them I stole from PTS. You also have to pay for that. But luckily, you can pay just $20 for, like, 72-hour access, and then just scrape every single manual page on it, and then save it for later. And that's, yeah, that works. I mean, it's just static manual information, not like you need it all the time. And there's like ForScan is what they call it. It's like a third-party software made by some sketchy Russian company, but like it can configure a lot more stuff than the official software can in most cases. Stuff like you can configure a module to be in a different, like to think it's in a different vehicle than it really is in, which unlocks features that maybe never were even part of that vehicle to begin with. Especially since they reuse a lot of modules like between Ford and Lincoln, so you can sometimes get like Lincoln features that are like Lincoln only in like your F-150. Like, you know, you can reconfigure things. Current state of things, what I'm doing now, I'm running that Gateway Modules OS. You know, it's just Linux. I'm running it in like QEMU, so I can sort of attack some of those things because, yeah, I mean, obviously it's easier to do something in an emulator because I don't actually have like shell access to the device yet. There are some interesting attack vectors, right? I have that Ethernet adapter, so I can plug into it, send packets at it. There are a whole bunch of open services, you know, listening on ports that are like they wrote themselves in like C. So I'm guessing there is hopefully a vulnerability there somewhere. The one problem is they actually did like Linux like properly. They're using SE Linux to like configure like secure profiles for every process. They're also using DM Verity to make it read only. They use like a squash FS image that's like completely read only. And so yeah, you can't like modify the OS. Yes, question? They call it Wind River. Oh, yeah. Repeat the question. Is this like some custom Linux? Yeah. I mean, it is using components of like a lot of normal Linux, like it's using like systemd and stuff. But they call it Wind River Linux. Apparently, that's like a company that does like contract like custom Linux stuff, I guess. Yeah, I mean, it uses components, but then a lot of custom stuff that they ported over from their like QNX operating system, like they just copied and pasted a bunch of services. That's all the stuff you see in the log there is kind of tiny. It says like cat A, cat B, cat C. Anything that says category like that is copied from QNX. Anything that doesn't is like a native Linux service. They've also got like a custom bootloader, I think that's in my slides, involved that like is kind of, that also might have some vulnerabilities because it looks entirely custom and it communicates with Linux over a custom file system, and that they implemented in user space using Fuse. I would like to question that, but that's just what they did. Yeah, right now the annoying thing in QEMU I need to figure out how to disable is there's like a watchdog type thing that like is very mad at me because all the services are like complaining that they're not actually in a vehicle. You know, it tries to talk to the powertrain control module and it can't, and it's like something's wrong, I better reboot. So it does that every 2 minutes, but I could probably figure out how to disable that. Haven't yet though. Hasn't mattered that much. Yeah. I think that's all I had. I just had some photos. Oh yeah, this is how I eventually planned it. Like before, I've been using the eBay modules like that I got from eBay. It's really cheap to get F-150 modules, even for like 2024, 2025 modules, just because F-150 is like the most popular vehicle and there are many of them crashed. So, you know, that module MSRP is for $2,000, but you can get it on eBay for under $200, despite it being basically brand new. So that's fun. But when I eventually attack a real vehicle, probably I'll try and attack, there's just behind the seat here, this Ethernet plug that's really easy to access. That would be really nice if I could attack there and not disassemble the entire center console. Yeah, I think that's basically it, unless anyone has questions. Also, I have this Discord server where I just dump information in. There's a lot of information there. If you want to get a copy of like the Linux and emulate it and like try and attack it, you know, you can. I have a GitHub repo that has the scripts to like emulate it in QEMU. Yeah. Any questions? Yeah. Unfortunately, they do have a bug bounty program, but it doesn't pay bounties. Like it's on HackerOne, but it just I haven't seen anybody actually get bounties from it. So I've just been doing this mostly for fun because I want to like hack my own vehicle and like maybe use the Com AI stuff. Um, Maybe if I found something severe enough, I would report it to them and see if I can get them to give me something. But like, yeah. Any other questions? Hmm? Okay, you wanna?
I was going to say, in the same vein, what is your ultimate goal besides just fun? Like, can you compromise message authenticity of that Tron protocol you're talking about?
Yeah. Basically, I figure twofold, right? If I can get code execution on the gateway module can forge all the messages it wants because it has to. Like that's how it routes messages between the different networks. And it would be really cool to get like that open source self-driving stuff working. To do that, I need to forge messages like from the self-driving module. So that would be kind of cool if I could do that on my own vehicle. That was basically why I started doing this.
And I have to ask, can it run Doom?
I mean, yeah. I mean, the newer versions literally are just running Android on the head unit. You could just, I mean, I think you might have to root it or something, but you could probably just like run Android version of Doom on it.
Is there a specific avenue you're trying to go at to attack that gateway module? Like, are you trying to go through the, I forgot what it's called, but the main like UI portion
No, because I mean the infotainment system. It just seems like it's indirect, right? Because even if you compromise the infotainment system, it is a separate module. It's just connected via Ethernet, so I'd still have to like do like lateral movement and compromise the other one. But since I have physical access, I can just plug directly into the gateway module and attack it directly via Ethernet. There are a whole bunch of protocols it runs that are custom. There's one they call Token Manager for so-called debug tokens. Basically, Forge sends over a TCP socket these magic like signed messages, and it unlocks a whole bunch of debug features like ADB. They use ADB even though it's Linux. So, you know, if I could figure out a way to forge those debug tokens or like break the parsing of the debug tokens so it let me unlock that, that would be cool. We'll see. That
you're more focused on finding like a physical attack, like if you already have physical access.
Yeah, because I mean it's for my own vehicle, so. But there is, like I mentioned, that photo of like this Ethernet connection goes directly straight to the gateway module. So if I could like plug in there and attack the gateway module over Ethernet, that would be really easy from a physical perspective because it's just like behind the seat. Okay, what's your question?
Okay. Do you think it's more secure to use a key fob, like remote unlocking stuff, or an actual turnkey? And if so, where would you store it?
I mean, I mean, in all cases, right? It's okay, yeah. Do you actually want an answer to that question? I mean, basically, in all cases, the same module is doing the ignition process. Like, there's just a module that, when you have a physical key, it just like because there are trims that still have physical keys. You know, there's a transponder in the physical key, and so that same module does it even if it's like keyless or if it has a physical key. The actual turning of the key does basically nothing. Yeah.